All right, welcome back. Today we are going to learn the last method to solving systems of equations, and this method is called elimination. If you have not read the top three paragraphs at the top of your paper, stop the video right now and read that to yourself so you know what the heck it is that I am talking to you about. All right, so the first thing we have to do with elimination is we have to make sure that the equation is lined up. So if you look at the four systems here, like these four right here, these are all lined up. And what I mean by lined up is that the x values have to be lined up, the equal signs have to be lined up, the constants and the y's. So here, this went the constants lined up here, the equal sign, the x's, the y's. There's many different ways you can line it up, but you just have to make sure y's on top of y, equal signs on top of equal sign, x's on top of equals, or x's on top of x's, and constants. So here this one went x, y, constant, and then equals to constant. That's kind of rare, but you can do that. So in order for elimination to work, everything has to be lined up. So if you take a look at this next one, I'll go ahead and help you line this one up. If you notice, it goes 2x equals 4y plus 6, and then this one says x plus 1 equals y. So there's a couple things that you can do. One thing I can do is I could take this 6 right here and I could subtract the 6 and get it to the other side. So that's one thing I could do. I could do it like this. I could say, all right, if I take the 2x equals 4y plus 6, and if I subtract 6, I'm going to get it to the other side. So then I'll have 2x minus 6 equals 4y, and then I could rewrite the other one underneath it so it says x plus 1 equals y. Another way to do it would be to look at the bottom equation, this one, whoopsie, this one right here, and I could move the 1 over with the y. So if I move the 1 over with the y, then I would have to subtract that 1 like this, and so it would be x equals y minus 1. And then I'll rewrite the top one over top of it underneath it. So it's 2x equals 4y plus 6. So if you think you have it, stop the video right now and take a minute to line up the next three. And there's different ways that you can do it, but you just have to make sure you get it lined up. And remember, whatever you do to one side, like if you want to move a term from one side of the equation to the other, you have to do the opposite operation or it doesn't work out. So stop the video and try the next three. So this next one's a little bit different because no matter what, you have to move either something in both equations or two things in one equation. So there's a couple different ways to do it. So just looking at the top, if I want the top to look like the bottom, then you have to get y alone, which is then going to cause some issues because to get y alone, I'm going to have to divide by 2. So that's going to make my life a little bit harder. So let's look at the bottom. So I'm going to take the bottom and I want to get my x's and y's to one side and my constant to the other. So basically I'm just basically going to switch where my y and my 5 are, right? I'm going to subtract y and add 5. And I'm just going to show you, I'm going to do them both at the same time. Like a lot of this, at this point you really should be able to do this sort of thing in your head. So when I subtract the y, that goes away, but it's now over on the right hand side, and then I'm going to add 5 to both sides. And then that goes away. So then you have 5 equals 2x minus y. And then the bottom, I'm going to rewrite it again underneath it. So it's 3 equals negative x plus 2y. Now that's not the only way to do it. That's just the way that I chose to do it. The next one, what I would do with the next one is, again, just get x and y to one side. And that's really easy. With the bottom, just add 2x to both sides. And then when you write the 2x, put it first. So it's 2x plus 6y equals 3, and then right underneath it I'm going to write 4x plus 3y equals 12. Okay, again, that's not the only way to do it. You could take the top and subtract the 4x, and then you'd have the 3y lined up with the 6y, and then you'd have negative 4x lined up with the negative 2x, and then you would add 12. So like these aren't necessarily the only way to do it. The next one, I think it would just be easier to get the y alone on the bottom and add 1 and subtract 3x. You don't have to. You could subtract the 2x on the top and subtract the 10 and make it equal to 0. You could even just leave the 10 there. You could add the 1 on the bottom to the 2, and then on the top you could bring the 2x over by subtracting 2x. I personally just think I like to just move the bottom one around as well, so I can just do the work. That's going to give me 3 there, and then I'm going to also subtract the 3x. Subtract the 3x. So then that goes away. So then I have y equals 3, because I did 2 plus 1 minus 3x. And on the bottom I have y equals 2x plus 10, but I need to write the 10 first. 10 plus 2x. Does that make sense? Again, not the only way you can do it. So moving on to the next page. All right, so if you can see here, there are all of the steps here for how to do elimination. So I'm going to walk you through it. The first one, make sure both equations are lined up. And if they're not, we're going to line them up. So if you look at this, they're not lined up. So I personally think the way to get them lined up, it's going to be easier to move the 2y over to the left and make it negative 2y. So we're going to write it as, I'm going to subtract 2y from both sides, cancels out, so I'm going to have x minus 2y equals 6. And then I'm going to rewrite the top one right underneath it. So I'm going to make it 3x plus 4y equals 8. So now, the next thing that we're going to do is we are trying to eliminate an x value or a y value. And the way we eliminate this is we are going to eventually add these equations together. So when we add these equations together, we want to eliminate one, so they have to be opposite coefficients. So if I wanted to eliminate 3x, I would need this x up here to be negative 3x. Since negative 3x and positive 3x gives me 0, that's what I would need to do. If I wanted to eliminate the y, I would need to figure out how to make these so that they're opposite coefficients. So right now, the bottom y is a 4y and the top y is a negative 2y. If I multiplied the entire top by 2, then I would make it negative 4y. So I have 2 options. Every time I do this, I have 2 options. You can multiply one or both of your equations by something so that they get opposite coefficients. So we have a choice. We can eliminate the x or we can eliminate the y. Because I already have a plus minus here, I really like just multiplying the whole top by 2. So that's what we're going to do. So I'm going to take the top equation and I'm going to multiply it by 2. So I'm going to take this top equation and I'm going to multiply the entire thing by 2. All right? When I do that, you have to multiply every term by 2. So I'm going to get 2x minus 4y equals 12. And then I'm going to rewrite the other one right underneath it. 3x plus 4y equals 8. So now I'm at the next step. I'm at here. I'm now going to add the 2 equations together. Okay, so this is nothing we've ever done before, but it works. Okay, when you do that, you're going to notice that one of the variables disappears, right? So I have 2x plus 3x is going to give me 5x. Negative 4y and 4y give me 0. So that cancels out. Then I bring the equal sign down, and then 12 plus 8 is 20. So then step 4, right here, we now have an equation left with only one variable. So we're going to solve for that variable. 5x equals 20. Well, we already know how to do that. We divide both sides by 5, and we get that x is equal to 4. So what we've just done is we found the value of x. But if we know the value of one of the variables, we can very easily get the other variable. So the next step right here, plug this value into either equation in the original system and solve for the other variable. So I'm going to take this and I can plug this 4 in for x right here. I can plug it in for x right here. Basically either one. It doesn't matter. I think it's going to be easier to put the x right here in the bottom equation. So that's what I'm going to do. So getting rid of that, we now know that x is equal to 4. So I know that x is equal to 4. So I'm going to put that in for x into the bottom equation. I could put it into the top, and then I'm going to solve for y. So this, we are on step 5. So we do 4 equals 2y plus 6, and then just solve that equation for y. So I'm going to subtract 6 from both sides. 4 minus 6 is negative 2 equals 2y, and then I'm going to divide everything by 2. And you get that y is equal to negative 1. Next step, write your solution as an ordered pair. Okay, so we know x is 4, y is negative 1. So the ordered pair, the solution is going to be 4, negative 1. Remember, ordered pairs are always in parentheses, followed by a comma, or comma in between, x comes first, y comes second. So the very last step is check your solution in both equations. And that's the annoying thing. It's got to work in both. If it doesn't work in both, then you made a mistake. So I'm going to go ahead and make this disappear. So for my check in the top equation, I'm going to do 3 times 4 plus 4 times -1, and I'm going to see, does that actually equal 8? So 3 times 4 is 12, 4 times -1 is -4, 12 minus 4 is 8. So we see that it works in the first one. But it's not good enough, it's got to work in the second one as well. So I'm going to put 4 in for x, and I'm going to say 2 times -1, because -1 is y, plus 6, and I'm going to go through and do it. 2 times -1 is -2, and -2 plus 6, what do you know? It is 4. So I do get 4 equals 4. So it has to work in both. Sometimes you will find that when you solve these problems, it will work in one and not the other. It's because you made a mistake somewhere in probably the second equation you were working with. So you just got to make sure it works in both of them. All right, so number 2. This one, if you feel like pretty confident about doing this, go ahead and stop the video and then come back and see if you've done it. I totally think that's a really good plan. All right, so looking at this first one, first step, make sure everything is lined up. Well, if you look, it is x, y, equal sign constant. Everything's lined up. Second thing, try to eliminate a variable. If you look at this right now, the way I'm looking at it, I can eliminate the y's already. So in this problem, I don't actually have to multiply the top or the bottom by anything because automatically these y's, boom, cancel out. So I'm just going to go ahead now and add the two equations together. So 2x plus -4x gives me -2x. Equals 10 and -4 gives me 6. I'm solving for x now, so I'm going to divide both sides by -2, and I'm going to get x is equal to -3. And so now I know that x is -3, so I'm going to plug that x into either the top equation or the bottom equation and solve for y. It doesn't matter. I'm going to go ahead and put it into the top equation. So I'm going to have 2 times -3. And if you've already done this problem and plugged it into the bottom equation, that's fine. You should get the same thing as me. So I have 2 times -3 minus y equals 10. Well, 2 times -3 is -6. Minus y equals 10. Get y alone, so I'm going to add 6 to both sides. And I'm going to get -y is equal to 16. And then I'm going to divide both sides by -1. And when I do 16 divided by -1, I get y is equal to -16. And so now my answer is an ordered pair. So I'm going to write my answer as -3, -16. And so that's my answer, and now I have to check it. So I'm going to plug it into the first equation. So my first equation is 2x minus y equals 10. So I'm going to do 2 times -3 minus -16 equals 10. And so 2 times -3 is -6. Well, minus a negative is plus, so -6 plus 16 is equal to 10. And I'm going to add and get 10 is equal to 10. So it works in the first one. So we got to check the second one. So I'm going to do -4 times -3, because that's your x value, plus -16. I'm just going to write -16, because plus a negative is just minus, equals -4. And then I'm going to do -4 times -3 is positive 12. Positive 12 minus 16 equals -4. That's a true statement. -4 is equal to -4. So the check works out. All right, let's try the next one. All right, so this one's a little bit different than the other two that we've done so far, so stick around and watch for this one. One thing to note is that if you notice there are C's and B's instead of X's and Y's, if you have any variables that aren't X's and Y's and you don't know what the variables stand for, meaning you can't decide what's the independent or dependent variable because you don't know what they stand for, then just put them in alphabetical order. So you would put, because it's B and C, so you would just put B first and then C. All right? So now this one, first thing we need to do is we do need to actually line this guy up, right? So 2 ways I can do that. If you note, I could take the top and I could subtract 2b from both sides and put it on the other side, or I could add 3b to the other side and then I'll have the 3b and the c on the same side of the equal sign. So I'm going to do this a little bit differently this time. I'm going to go ahead and subtract 2b because before we had the variables and then equal to the constant. Let's do that. Do it a little bit differently this time. So I'm going to subtract 2b from both sides. When I subtract 2b from both sides, on the top equation, what I end up getting then is 6c equals negative 2b because I'm subtracting it. And I'm writing that first because it's first and the one below it. So negative 2b plus 8. Then I'm going to do negative 5c equals negative 3b minus 2. All right, so now I need to decide, well, which variable do I want to eliminate, right? So let's look at the c's. Right now, I have negative 5c and 6c. So if I wanted to eliminate this guy, right now there's not just one that I can multiply, right? There's not a number I just multiply 1 by to get 6 and then this one to get 5. So what I have to do is I have to multiply them both by something. So the multiple that they have in common is 30. So if I wanted to cancel them out, I would multiply this whole top one by 5 and this whole bottom one by 6. And you already have opposite numbers, so that would be cool. If I wanted to eliminate the b, well, I need to think about, well, what multiple do 2 and 3 have in common? Well, that would be 6. And since they're both negative, I would need to multiply one of them by a negative number so that I have one positive and one negative. Okay, so if I wanted to eliminate the b, I would need to multiply the top by 3 or negative 3 and the bottom by 2 or negative 2. But you'd only want to multiply one of them by the negative. So I'm going to go ahead and just eliminate the c. So to do that, I'm going to multiply the top by 5, and I'm going to multiply the bottom by 6. All right? And again, you didn't have to do this way. You can eliminate the b's. So when I do that, I multiply 6c by 5, I'm going to get 30c. And then negative 2b times 5, I'm going to get negative 10b. And then 8 times 5, I'm going to get 40. And then negative 5c times 6, I'm going to get negative 30c equals negative 6b times 6 is negative 18b. Negative 2 times 6 is negative 12. And so now I'm going to add my equations together. 30c and negative 30c, that cancels out. But you know what? There's nothing else with it, so I have to write the 0. Because now I'm going to have 0 equals, well, negative 10b minus 18b is negative 28b. And then 40 minus 12 is 28, so I get plus 28. So now I have just a b, so I'm going to solve for b. So to get b alone, I'm going to subtract 28 from both sides. And 0 minus 28 is negative 28 equals negative 28b, and then divide both sides by negative 28, and we get that b is equal to positive 1. And so now what do I do with that? Well, I take that b, this b value, and I'm either going to place it in the b for this equation or the b for the bottom equation. I personally think it's going to be easier to put it in the b for the bottom equation. It doesn't matter which one. You can do either one and you'll get the same answer. So I get negative 5c equals negative 3b minus 2. And I'm going to replace the b with 1, so that's just negative 3. So I have negative 5c equals negative 3 minus 2, and negative 3 minus 2 is negative 5. So I get negative 5c equals negative 5, divide everything by negative 5, and I'm going to get that c is equal to 1. So the answer is going to be, remember, bc, but they're both the same number, so the answer is just 1, 1. So that's the answer to the question. So you want to make sure you circle that somehow or put it in a box so that I know that you know that that's the answer. So now we're going to check. So I encourage you right now, stop the video, actually do your check on your own, and then tune back in and see if you did it right. So here's the check. I put 1 in for B and 1 in for C. I went through and I did it. The top one, I got that 8 was equal to 8. The bottom one, I got that negative 5 was equal to negative 5. If you got this one wrong, stop the video, look and see if you can find your mistake. All right, if you've got the hang of it, keep on going. Stop the video, try the problem, fast forward it, see if you got the right answer. If you still need a little bit more, let's do this one. So here, you're going to get the variables to one side. So I'm going to go ahead on the top here. I think it's going to be easy to get this negative 9x to the other side because x and y are on the bottom here. If you wanted to, you could subtract the 3x from the bottom and then everything will be lined up. I really like my x's and y's to be on the same side. It just ends up being easier at the end for me. So I'm going to add 9x to both sides. So when I add 9x to both sides, the 9x is going to go in front of the negative 3y. So I'm going to have 9x minus 3y equals 20, and then I'm going to have 3x plus 6y equals 2. All right? And then I need to decide, well, which variable do I want to get rid of, right? So in this case, if I want to get rid of x, I need to multiply the bottom by a number that's going to give me negative 9. So I would multiply by negative 3. If I wanted to get rid of the y, I would multiply the top by 2. I'm going to go ahead and I'm just going to do x because I've not done one like this before. So if I get rid of x, I'm going to multiply everything by -3, okay? So I'm going to have 9x minus 3y equals 20. I'm just rewriting the top equation. And then the bottom, I'm going to multiply everything by -3. So I'm going to get -9x minus 18y equals -6. And then I'm going to add everything. So 9x plus -9x gives me 0x, so I don't need to write that because I have the y's over here. So -3y and 18y gives me -21y equals, well, 20 minus 6 is 14. And I'm going to divide everything by -21. -21. And so now what I have is I have a fraction, right? My answer is a fraction. So I get y equals 14 over -21. Well, that's just a negative fraction. 14 and 21 are both divisible by 3, or by 7, sorry. So I'm going to divide by 7. So 14 divided by 7 is 2. 21 divided by 7 is 3. So I get that y is equal to -2/3. So the next thing I'm going to do now is I'm going to take that y, I'm going to plug it in for y somewhere. So I'm going to put it in the top equation. You can put it in the bottom equation if you want to. So I'm going to put it in the top equation. So plugging it into the top equation, I'm going to do -3 times -2/3 equals 20 minus 9x. And so don't freak out about a fraction. You can deal with a fraction, especially if you're multiplying it by a multiple of 3, right? So I'm going to make that -3/1. I'm going to cross cancel. The bottom 3 becomes a 1 and the top 3 becomes a -1. -1 times -2 is +2. +2 over 1 is just 2. So I get 2 equals 20 minus 9x. And then solve for x. So we're going to subtract 20 from both sides. 2 minus 20 is -18 equals -9x. Then I'm going to divide everything by -9. And 18 divided by -9 is 2. So I get that x is equal to 2. So the solution to the system is the ordered pair. Remember, x comes first, so it's 2, -2/3. So now we're going to check. And this time it says check by finding the intersection on your calculator. So I'm going to have you check this way because I want you to remember that we can find the solutions to these systems using our graphing calculator. So I'm not going to plug the ordered pair in. What I'm going to do is I'm going to change each equation into slope-intercept form, and we're going to plug it into our graphing calculator. So if you don't have your graphing calculator, get it out. All right? So first thing, we're going to take -3y equals 20 minus 9x. And I'm going to put that in slope-intercept form. So I've got to get y alone. So I'm going to divide everything by -3. So I'm going to get y equals 20 over -3 plus 3x. We're dividing everything by -3. And remember, a negative divided by negative is a positive. So that's the first one. The next one, I'm going to just go ahead and do up here. I'm going to subtract 3x from both sides. So that's going to leave me with 6y equals 2 minus 3x. Then I'm going to divide everything by 6. And then I'm going to get y equals, well, 2 over 6 reduces to 1/3, and -3 over 6 is -1/2 x. And so then you're going to go in your calculator. So I don't have a calculator on my iPad here, so you're going to just need to follow the instructions, right? If you know how to do it already, just do it. Turn off the video, just do it. If you forget, step 1, you're going to go to y equals. And then once you're in y equals, in y1, you're going to put one of these equations. For the division bars, here just put divided by. So like if you're plugging in this one into your calculator, you're going to plug in 20 divided by -3 plus 3x. And remember, the variable key is the key right next to alpha. It's the one that says xt, theta, n. And that theta kind of looks like a no solution symbol. And then so that you put 1 in y1, and then you can put the other one in y2. So in this one, you plug in y divided by 3 minus 1 divided by 2x. All right, you got those in there. The next thing that we're going to do is we've got to calculate something, right? So you're going to hit second trace because above trace says calc. So we hit second trace. And once you're in second trace, we are going to choose intersect. And then honestly, once you're in there, just hit enter, enter, enter. So to get the answer, you hit enter 3 times. basically. So those are basically the steps. And then once you do it, you should get your solution. And remember that negative 2/3 is negative 0.6 repeating. So that's what will come up for your y value. So at the bottom it should say 2, negative 0.6 repeating. All right, let's do one. All right, let's take a look at this one. For this one right here, it's not lined up, so I gotta line it up. To me, what's obvious is at the bottom equation, I want to subtract 1/3 x. If you want to, you could take the top equation and add y. I prefer to have x and y on the same side. So I'm going to subtract 1/3 x. So the bottom equation is going to say x minus 1/3 y equals 4. The top equation is going to say 3x minus y equals 6. All right, so let's take a look at elimination. We don't really like fractions, right? So like we don't want, I mean, you can multiply an entire equation by a fraction if you want to, but it oftentimes will give you more fractions. So like if I wanted to eliminate the y's, then if I wanted this to be positive 1/3, I'd have to multiply everything by positive 1/3, which is fine because you can find 1/3 of 3 and 1/3 of 6, but I want to avoid having to deal with fractions because sometimes you guys see fractions and you're like, oh my god, I can't do it, it's a fraction. So let's just avoid it, okay? So let's just look at the x's. If I want to eliminate the x's, I'm going to multiply the whole thing by negative 3. If I want to eliminate the y's, let's multiply the whole thing at the top, like this whole top thing, by negative 1, because then you could get that to be not negative 1, by negative 3. Because if you multiply this by negative 3, you're going to get positive 1, okay? Easiest thing to do, get rid of the x's. Let's just get rid of the x's, okay? So we're going to multiply this whole top by negative 3. Sound good? So multiply everything. I'm going to get on the bottom, or the top, I'm going to get negative 3x plus, well, 1/3 of 3 is 1. So I'm going to get y equals negative 12. The bottom, I'm going to get 3x minus y equals 6. So then I'm going to say, all right, my x's eliminate. Uh-oh, wait a second. So do my y's. So if all of these things eliminate, that means I got nothing. I got nothing over here. And I'm saying that nothing is equal to negative 12 plus 6, which is negative 6. We have a problem, right? All of my variables cancel it out, and I have a statement that is not true. So when you get something like this, that is no solution. So you can draw a circle with a line through it, or you can just write no solution. So think about what that means. When you have a system with no solution, what that means is you have two parallel lines, right? So if I took this top equation right here, or any of these equations, if I put them both in slope-intercept form, you would get that they would have the same slope. If I tried to graph them, they would have the same slope. They never intersect. So the clue that that's going to happen is you're going to get 0 equals negative 6, okay? Think about this. What if I got a true statement? Like what instead of 0 equals negative 6, I got 0 equals 0. Well, what that would mean, you have a true statement, right? So if you have a true statement, that means that you have the same line. So if you get a true statement here, it would be infinite. All right? So that's all for today. You need to finish the rest of the packet on your own. The answers are on the last page at the bottom if you want to just double check to make sure you're doing your answers as you go. Good luck.